All right, so we're just going to go over some examples of using the wave equation. And there are some tricky examples, so there are some good visualization ones in this and those. All right. Remember, all right, actually, what is the amplitude of, let's say we're given a function what is the amplitude of that? Remember the equation had your amplitude, it was whatever number is right out front, so and whatever value is positive right out front. So right here, the amplitude is actually, it's a 1, because 1 times sine x is still going to be sine x. So the amplitude here, you know, the number out front, the positive value of that, so we figured that the amplitude here is 1. Go over the second one. Let's not call it f of x, let's call it just y. I'd like to switch things up. 7 cosine Alright, let's do that. I mean, here it's pretty obvious that the amplitude is just 7. So the amplitude here is the number out front, that's 7, so the amplitude is. For example, for amplitude. Yeah, that's a good one. Now I'm noticing on a couple of your papers, you know, looking around, I'm seeing some people just writing that the amplitude is equal to -9. What's the problem with that? Why is it not -9 here? Yeah, you in the front. What? Why? So, because it's going to be positive. The amplitude it's a distance. The amplitude's distance. So right here, distance cannot be negative. Amplitude is a measure of its distance. So the amplitude here is not -9. It is just 9. You have to get rid of that negative. You're just extracting that positive value. You're taking the absolute value of whatever that number is up front. Be cautious about that. Amplitude is a distance. All right. In amplitude, 4. What's the midline of that? You want to remember what the midline is? It's just the number right here. So the midline here would be C would be just 3. If you had an example where, let's say, you had it, so it would be something like -7.5. Remember, the midline is just, it's the value at the very end. So right here, you could even rewrite it as plus a -7.5. Because you're going plus negative, so that's a negative. So right here, C, it's very obvious that C is equal to negative 7.5. So the midline can be negative, like the amplitude. So that would be number 5. Let's go on to number 6. Say you're given a wave. It could repeat. Let's say the value up top is 20. The value down below, all right, let's make that number 10. So what is the value in the middle? Remember, midline is the value. It's the line right here. So we will what that is. I mean, here it's pretty obvious that it's 15. So you're going 10 plus 5 plus another 5. It's like you cut it in half. But I'm trying to get everyone in the habit of understanding that midline, the word middle isn't. So when you think about this, these could be irrational numbers for harder examples. So what I'm going to do is I'm going to just take the average of the two values on the outside. This even works for negative numbers. So C here would be the average of those two values on the outside. So it'd just be 10 plus 20 divided by 2. In other words, C would equal, so 30 divided by 2 is 15. So the midline would be 15. For instance, you could have, here, let's try, let's make this 5. Let's make this negative 17. All right. So that one's a little trickier. You could try and count them, but all right. So we're just going to do the average of the outside values. So here it'd be 5 plus a negative 17, divided by 2. We're just taking the average of those two numbers, so that's why I'm dividing it by 2. In other words, 5 minus 17 over 2. So 5 minus 17, that is a negative 12 over 2. So it's negative 6. Here is negative 6. That's how you do that one. Let's switch this one up. Yeah, what is the amplitude? And up top, we have the value. This one we'll do it kind of cool. This one will be a good one. All right, let's have this be negative 10. This be negative 50. What is the amplitude of that? All right, well, there's a couple ways of doing this one. The first way is to do, what is the distance from here to here? So what's that distance? Remember, you want to go top minus bottom here. So you're going minus 10 minus a negative 50. That'll give you that distance. You're going top minus bottom. Remember that it's important with those two negatives. So it's negative 10 plus 50. In other words, that distance is 50 minus 10, so it's 40. Now, since this distance right here is really 40, the amplitude is half of it, because it's just half of that distance. So you're going to take 40 and you're going to divide it by 2, So that value is 20. The amplitude here, so that would be your amplitude. Kind of a fun one. You know, the other way you could do it, you could find the midline, still using the same thing. You go minus 10 plus a negative 50 divided by 2, and then say, well, what's the distance from there to there? You can do it that way as well. You know, whatever you're feeling, I guess. So, all right, that's 7. Let's go over 8. We did amplitude. Let's go over what is the wavelength? Wavelength of, let's say, y equals 9 sine of 3x plus 1. Yeah, let's do that one. What is the wavelength? Everyone remember the formula? Remember, it's a sine of 2 pi over lambda x minus phi plus c. That's the equation. Now, this one it's kind of tricky, and we'll get into this in some other examples. But what you will notice is that if I distribute this 2 pi over lambda to phi, so I get 2 pi over lambda times phi, you have some kind of, some number left over. So really, phi here is equal to 0, which means we can ignore it because there's no phi, there's no other term over here. So since our phase angle is 0, we can ignore it here. So it's just the 2 pi, this value connected right to the x is always going to be your 2 pi over lambda term. And again, wavelength is just lambda. So we're going to try and figure out what that is. You're given that this 3, whatever the number is connected to the x, you're going to set that equal to 2 pi over lambda. So you get 2 pi over lambda is equal to 3. Trying to figure out what lambda is. Lambda is in the denominator. I need it out, so I multiply both sides by lambda. So I multiply both sides by lambda. I get 2 pi is equal to 3 times lambda. Did someone have a question on that? Yeah, all I did here was I multiplied to get from here to here. I needed lambda out of the denominator. I'm trying to figure it out. So I multiply both sides by lambda, so it's up here, but it's because I'm multiplying both sides by lambda. Those are canceling out, so you're left with 2 pi is equal to 3 times lambda, so it's right there. At which point in time I divide both sides by 3, so I get lambda, because the 3's are gone, is equal to 2 pi over 3. That's how you do that one. Let's do another one. That was a good example. Let's do cosine though this time. And you know what? Let's switch it up a little bit more. Let's have it be 7 pi over 3x. All right, wavelength. Remember, first step, the term right next to the x. Set that value equal to 2 pi over lambda. Even if you had another number right here, you would still set that term, whatever the term is, right next to the x. You're going to set that value equal to 2 pi over lambda. It doesn't affect it. The phase angle does not affect what lambda is going to be. So it's whatever term is right. So here, you know, you could multiply both sides by lambda. I just think it's easier to cross multiply at this point. So we go 7 pi times lambda. It's 7 pi lambda is equal to 3 times 2 pi. So that's 6 pi. I divide both sides by pi. They cancel out. So we get 7 lambda is equal to 6. So lambda is really equal to 6 over 7. Let's go over another example. Phase angle. Oh, I did not like how that looked. Angle of, let's say, let's just make the sign 9. Let's make it -9. Sine of 3x plus 6. And then let's do minus. I don't want to repeat 3. Minus 7. All right, what's the phase angle of that? Again, recall equation of a line is a sine of 2 pi lambda x minus phi plus c. And the phase angle is phi. So we're trying to figure out. Now, the way that, you know, when I look at this one, I'm going to show you this one. This one's kind of a trick. When you look at it, you might say, hey, if I set this whole term equal to that, I could potentially figure out what phi is. So you could spend, you know, you could try and set 2 pi over lambda equal to 3, because 2 pi over lambda is equal to 3. Figure out what lambda is, and then try and figure out what phi is. But the problem is that if you figure out what lambda is, you plug it back into there, you're still going to be left with that, you know, that left over at the end of the day. So what I'm going to do here is a very specific step. Instead of, you know, thinking of it like this, this is a very sneaky move. It happens a lot. So I'm going to set sine of, you see that number right next to the x? I'm going to put a 3 right there. And then what I'm going to do is I'm going to have parentheses on the inside. And then I'm just going to have my minus 7 on right there. And I'm just going to have some stuff here. And I'm going to try and set this inner term right here equal to that value. Because this value right here is really just some number right there. So this number right here is really 3. So if I have it and I can figure out what lambda is, I mean, if I can figure out what my phase angle is, I'm good. So I'm pulling out the 3 right here. That's the trick. All right, so I'm pulling out the 3, that number right there, and I'm just seeing what phi would equal. So right here. Now, what would happen if phi was equal to 2? If phi was 2, you would get -9 sine of 3x, 3 times a -2 would be -6, but we need that positive. So right here, you can kind of see that phi would be equal to -2 because it has to be positive right there. Because it would be, you see that -2 here? If I substitute it, we're going -2 minus a negative is going to be a positive, so that would give me that value there. And it's kind of sneaky what I did right there. I'm wanting to point out another way of doing this, is that you could try and guess it, but the way that I typically do it is I have this and this right here. I could just set 3x minus phi equal, set this right here equal to 3x plus 6 and just solve for phi by hand. So I get 3x minus 3 phi is equal to 3x plus 6. My 3x's cancel out with each other. So minus 3 phi is equal to 6. So my phase angle, I divide both sides by -3, is equal to -2. So my phase angle is equal to -2 here. I mean, you could do it that way, but I'm showing different ways of approaching these problems here. I typically do this way right here, just out of habit. Now, is this a shift to the left or shift to the right? It's a shift to the left here. It's a shift to the left because it's negative. If it was positive, it would be a shift to the right. All right, let's do one more where it has everything in it. All right, so let's have this be -8. Let's get some fractions going. All right. And let's say for this last example, we're just gonna, what are all missing parts of this? Okay, so we're gonna talk about everything here. Now we could go into period and stuff like that. We're not going into frequency. All right, so we're just figuring out what we've been talking about so far. So right away, let's get, let's just write out the equation. Y equals a sine of 2 pi over lambda x minus phi plus c. All right, we'll just go right down the line. A stands for amplitude. Technically, the absolute value of it. So the amplitude here. See, there's a -11. So a -11, its absolute value is positive, so it's going to be 11 there. Now, amplitude is done. A equals -11. The amplitude is the absolute value of whatever that value is. The amplitude is 11. Let's figure out what our wavelength is. We're on to here. So 3/4 must be equal to, so I'm going to set the number right next to the x, equal to 2 pi over lambda, and then I'm going to solve for lambda. So I get 3 times lambda cross multiplying is equal to 8 pi. So lambda is equal to 8 pi divided by 3. All right, so that's my wavelength. All right, so we did that one. Oh, that one's gross. Let's save that one for the end. I mean, that one's the best one, so we got to save that for last. C, what would C? C would be equal to 7 or -7? Yes, -7. It's just that value, so it's -7. It can be negative. So C is -7 here. So that just leaves us with our phase angle, phi. All right, so we just have to figure out what that is. So, and then we'll be done. All right, so what is phi? All right, let's erase this. what I'm going to do, remember the trick, is that you take this 3 over 4 term and you put it right on the inside of that. And what do I do next? I need more parentheses. I need more parentheses so I have something on the inside. Now I'm going to have it's going to be x minus, and then I'm just going to write phi in hopes to solve for it. And then and we don't care what comes after it. So what we care about is this part right here. We're going to set that equal to this. Remember, this is equal to your 2 pi over lambda term. So you can do it like this. So you can set that, my 2 parts in pink, you can set those things equal to sides. Figure out what it is. So let's do that. You get 3/4 x minus 8 is equal to 3/4. I'm going to set that equal to that x minus phi. In other words, 3/4 x minus 8 is equal to 3/4 x. You're taking that and you're multiplying it by it, so it's minus 3/4 phi. Law of fractions. These terms here cancel out. Subtract them on both sides. Let's clean up this mess. So negative 8 is equal to negative 3/4 phi. I don't like dealing with negatives. Let's get rid of these negatives. I'm just multiplying both sides by -1. So multiply both sides by -1. The negatives are gone. At which point I multiply both sides by 4. I get 32 is equal to 3 times phi. I divide both sides by 3. I get 32 divided by 3 is equal to phi. So I just divided both sides. So our phase angle is equal to 32 over 3. That's how you do that one.